variation of mass with velocity. Let us consider an inelastic collision in a moving frame whereby two masses, say balls, of the same size are moving with the same velocity but in opposite direction, and after collision they stick together and come to rest. This guy is moving with v in this positive direction and this one is moving with v in the negative direction before collision. After collision they will stick together. They have stuck together and their new mass is capital M. But I would say it's this one is M1 prime, M2 prime, T prime, X prime. So the observer is here, or it can be on any of the balls as we describe them. So of course T here will be much later time, T2, T1 prime. So we want to know what somebody on the ground will see. So remember, this frame is also moving away. Since it's our moving frame, we assume that the velocity also is v. So v is equal to this v and it's equal to this v. So these balls are moving in this frame that is moving with v. So that's what we are saying. So the observer on the ground frame or on the stationary frame will see that for ball 2, let's assume that this is his ball 2, M2. Because this frame is moving with v in this direction and this ball is moving with v in the opposite direction, he will see it as being stationary. So that means that the v here is 0, velocity u if you like, or ux0. Also, when this mass is stuck together, it's no longer moving in this frame, but he will see it in this frame as moving with v, ux1 plus 2 if you like, as moving with v, moving with this velocity of the reference frame, because this guy now is at rest in this frame. For ball 1 in S frame, he will see, if we use Lorentz transformation of velocity, ux is equal to, for this one, ux is equal to ux prime plus v all over 1 plus ux prime v over c squared. That's what he will see. In this moving frame, our ux prime of this object is v. So that's he's taking it one after another. He has known what this one will be, 0. He has known what this one will be, v. We want to know what this one will be. So it is equal to v plus v. This v is what I have put here with this pen, over 1 plus v times v all over c squared. So he will see 2v over 1 plus v squared over c squared. Remember, if we use this same thing for ball 2, he will see u2x, if I like, here. We want to show that it will be 0. u2x prime plus v all over 1 plus u2x prime v over c squared. So this guy is moving in the negative direction So it is minus, so it's equal to minus v plus v all over. Of course, you know that this guy is 0 on top, so it's minus v squared over c squared. So it's 0. So we have confirmed that he will see 0 on this one. Also, this guy is at rest here, so he will see for this 2, 1 plus 2, he will see u big M prime plus v all over 1 plus u big M prime v over c squared. This guy is 0, it's not moving. 0 plus v all over 1 plus 0 times v is 0 over c squared. So you see that it will see v over 1, which is v. So we have shown mathematically what this guy will see in the various frames. So let us continue. So from this equation, okay, let me just say you have v squared over c squared minus 2 over ux v plus 1. Okay, so this guy is equal to 0, and you see that this is a quadratic equation in v. From here, you see that our a is equal to 1 over c squared, and our b is equal to 2 minus 2 over ux, and our c is equal to 1. So if we compare these two equations, that's what you have. So we can solve this thing using formula method. Minus b, that's x is equal to, x12 is equal to minus b plus minus square root of b squared minus 4ac all over 2a. Anywhere you see minus b, you put 2 over ux all over, that is b, over 2a. 2a is 2 times 1 over c squared, that's 2 over c squared plus minus, you do the same thing in the bracket. Anywhere you see b squared will be 4 over ux squared minus 4a. 4c is 4 times a, that's 4 over c squared. 4 over c squared all over 2a. 2a we have found to be this, 2 over c squared. C squared over ux plus minus. So we put it, so we have this c squared over ux into this guy now will be 1 plus minus square root of 1 minus this guy is 1 ux squared over c squared. So that's what we'll have, but we'll take the negative 1, and if we take negative sign, that's the only time ux will be equal to 2v. This guy will be 2v, is equal to that. Ux minus v is equal to ux minus the left hand side. So we'll have inside here, so that when this one comes in, it will divide this. When this one comes in, and this one will remain. So we will now have minus into 1 minus 1 minus ux squared over c squared. C squared over ux times 1 minus ux squared over c squared. Then this bracket stays. Remember, there is 1. This guy now will be, this times 1 will give us this. So let's write it first since it's plus. 1 minus this one now is ux squared over c squared. That's what we'll have for our ux minus v. So if we do that, you see that the momentum before collision will be m1 ux that we are looking for plus m2 velocity is 0 is equal to, the mass now is big M, not big M prime, big M times V. So that is what we have, and you know already from here that M0 plus M1 is equal to that capital B, 2 of them bunched to give us this. So we can now put this equation here, and we'll have M1 ux plus this one is 0 is equal to m0 v plus m1 v. If we now put this into here, we'll get that, and that means that if we bring this is m1 over here, we'll have m1 ux minus v is equal to m0 v. We can as well say, therefore, because we want to know the mass 1, what mass 1 will be in that frame. Mass 1 will now be m0 v over ux minus v. And our ux minus v, we have found our v, we have found to be this. So we write it, our v is m0 c squared over ux into 1 minus ux squared over c squared. And now this we know to be this, we put it down, c squared ux square root of 1 minus u squared x over c squared into 1 minus square root of 1 minus ux squared over c squared. So this one will cancel this one will cancel this one. So we are left with m1 is equal to m0 over square root of 1 minus ux squared over c squared. So that is the variation of mass with velocity. So that if this velocity is 0, if ux over c tends to 0, that is Galilean or Newtonian physics, then it will be equal to m1 is equal to m. So that is how we obtain this important formula in relativistic physics. Kindly like and subscribe to the video. Bye.